Hello, everyone. Good morning, good afternoon, good evening, good late evening, good early morning. Thanks for being with us. A warm welcome to everybody here to our session on integrated geospatial information management. My name is Hartmut Müller. I'm Chair of Commission 3, Spatial Information Management. Today we have five speakers announced, and integrated geospatial information management is, of course, a hot topic. Geospatial information management has been done for a long time, but the integration is an issue we are talking about today. And I would like to welcome the first speaker. The first speaker is Jörg Lüthi from Switzerland, and he will give a talk about a very future-oriented topic, multipurpose building models for Switzerland. Jörg, I would like to invite you to introduce you very briefly yourself and then start your presentation. The floor is yours.
Okay, thank you, Hartmut. Yes, good morning, good afternoon, good evening, everybody. It's very pleasant for me to be here and to present our study. As Hartmut said, my name is Jörg Lüthi. I'm working in a cadastral organization in Switzerland, so in a private engineering company. And I work primarily on the transformation from paper to maps to digital data. And now I'm going to present the study we carried out on behalf of the federal agency in Switzerland. So let's see that my screen works well. Yes, okay. So I really like this topic. It was a great honor for us to do this study because, as you can see just on this image, we have a huge variety of buildings, types of buildings. And at the end, how can we derive information about these buildings in a homogeneous data model to, at the end, make it usable for all different kinds of purposes? So we carried out this study. And so just why we did this study. First of all, when we look at the demand for building data, you see that on the right side, this growing demand for data from SwissTopo for these buildings models over the last years. So we have this demand. And we have also many different sources in Switzerland. I will come back to that later. But these are not well aligned and harmonized. And we're struggling just when we talk about the term building, what is the correct meaning, the correct definition and interpretation of this term, not only in reality, but also in data science. And in general, we see a major movement towards the digital design, construction, and operation. So it's not only about the architecture, but also about the operation of buildings. And many companies, they just want to have not more maps on the layouts, but all digital data to improve the facility management. And together with that, we have keywords like building information modeling. We have new standards from ISO. And one very important thing when we have common building models, we have to talk about common identifiers. Okay, so this was the situation. The objectives of the study is that we wanted to develop the basis, not the actual model, but the basis for the initialization for a new and interdisciplinary data model. So we wanted to achieve a multi-purpose building model. It's kind of, it's always called official building model. So it should be an official source, some legal binding source as well. So that's why we always call it official building Switzerland. And associated with the topic, we had different tasks. First of all, it's all about the business. So we need to know the actual need and the potential of this product. We have to find a definition for the term building to know at the end what is one discrete object in the database, develop a draft data model. And by doing that, we want to ensure that we can cover also existing national and international standards. And then at the end, develop a roadmap for further steps in this topic. So to start with, we had a stakeholder assessment with a variety of users, current users of building information. And it's also quite interesting for me to see how different the organizations are which are currently using building data. So we had interviews with organizations representing the legal view, normative views, also best practice, so also standardization organization. Then a bit from the wider scale, spatial planning, with all kinds of concepts and designs of the overall landscape alignment, but then also statistics, insurance, emergency operations. They all want to know different informations about the buildings. And then at the end, obviously, the entire construction chain we wanted to cover. And therefore, we had interviews with different organizations in these chains. So I mentioned before that we have existing building data, and we kind of classify between official sources and other kind of sources. And the official sources are quite important ones. So first we have on the lower left the Swiss Buildings 3D model. That's the product of the Federal Mapping Agency. But we do have also in our official cadastral data, we have not only the property, but also building footprints in 2 dimensions. And last but not least, we have the Register of Building and Dwelling, which is also an official register, which is fed primarily by the planning permits. So quite a different process associated to actually establish an information about a building. So when we look at some of these official sources, just here a very small sample of a comparison, what we often see is that we have different discretization of the objects. We have in here the green outline. You can see this is only one object in a Swiss building, but in the cadastral data, because we have different properties, we have the multiple objects. And on the other side, we have some buildings or some objects in the Swiss building data set, but not in the cadastral data, because it is not considered as a building in this definition. And we do have also geometric inconsistency between the data sets. So at the end, this brings us to the question, which is the correct, true representation of the reality for a single building. So this was to look at the existing data, and we had also a look on different international standards. I guess you are familiar with most of them, and it's interesting to see that we have well-established standards like CityGML, LandXML, LADM over the last years, and IFC, which are also ISO standards, but they all have a different focus. And by having that different focus, they have quite big differences between the representation of an object in the real world in the data. So this is a quite simple example, which was already produced more than 10 years ago. It's still valid. We still have these issues between the different data models. Just by having a different look at the reality, we have a different implementation, not only by using the same term differently, which gives us some problems in the semantic interoperability, but also that the spatial dimensions in the geometric solid, they do differ, which makes it very difficult to just exchange the data between the different sources or models. So this is kind of the data model side. So what we can state is from the situation analysis, we have this growing demand for building information. Also, the interviews showed that there are new needs coming, like for estimating the carbon footprint of Switzerland. by using the inhabited space and also combined with heating systems we know from the building permits. They all have an interest in a harmonized term building, knowing well that their definition is not precise enough and not concise all the time. And we have the differences between these terms. So they want to have the harmonized term, but also the harmonized and standardized building information. So there is a demand for this official building, but there are some other requirements. We have to make sure that we have no contradiction with legal building terms, with mass definitions. We want to use the existing data and standards and process. We cannot start with a greenfield approach. So these are quite important information we get back from the users. So for short, we have this definition then of the term building, which is always associated or linked between the purpose and then with the data model. And so we looked at some real-world object and considered, okay, what is a building? What is maybe a more generic civil work? And here you have a viaduct. On the top, we have the train running. But then someone decided that it would be a neat place to have some shops established there. So it's also a kind of a building. So therefore, we have started with a more generic approach to say we have a 3D civil work in general, and then a differentiation between transportation, building, and technical installation. So this way, we can ensure that we can also cover structures, as you can see here on the slide. And then we went a step further and developed a class diagram with very basic structures, how we can combine structures together to build bigger structures. And then once we have established this data model, we tried or practiced with different data sources. Here you see extrusion model, extrusion view with an IFC data set we used on the right side. And with the colors, you see all these kind of classes visualized here with the geometric primitives from the building. And then we did some further plausibility checks. On the left side, again, a bit bigger building complex. You cannot see it quite well, but there are overhanging and overlapping structures, one building on the top of the other building. So we had to ensure that we can also cover a bit complexer structures with our model. On the right side, again, a very nice building, Gary buildings near Basel, with a lot of floating surfaces. And we had to find out, okay, what is actually the wall, what is the roof, what is the slab. And so you can see here some very quick validation if the data model can actually hold the data for such a complex building. And so we could show that this data model with this validation is well suited for the demands for a nationwide data model, for a multi-purpose data set. We cannot cover every single demand of it, but we have designed the data model in a way that it can be extended for specific purposes. Like we have a new regulation on condominium ownership documentation in 3D with digital and spatial data. And so we have shown that this data model can be easily extended to cover also this purpose. And also, we showed on sample tests that we can use existing data in CityGML, which is currently the exchange format for Swiss buildings data, but also for IFC to integrate the coming data from new project in the IFC format. So, and then coming to the outlook, the discussion with the various stakeholders and the presentation of these ideas showed that this offers a very big advantage compared to the current situation where all the people have different data sources. Since it is an official data set, we have a greater reliability. We can easier integrate with other data, and also it's completely integrated existing business processes in the communities, municipalities, building permit process, but also in the cadastral surveying. We believe also that the timing for this standard is now perfect, as many of the construction processes are in revision now. And so this is kind of a unique possibility to use it or to use this time window now. So after this study, Swisstopo will work further on the conceptual phase to go into more details with the data model and then run more practical tests. The goal is that within 2 to 3 years, we should have everything prepared to then convert existing data set to the new model. Okay, that's almost everything from my side. Before we start the questions, just one remark. We've had this discussion, what is a roof and what is a wall? And since you have every now and then some snow in Switzerland, it's quite a simple definition. As long as you have snow lying after snowfall, that means that's the roof. And from the other side on, that's the wall. Okay, thank you very much for your attention.
Yeah, thank you very much, Jörg, for this impressive presentation here. Yeah, highly strategic. And I don't know how can I see questions that are asked? Are they in the comments window, or where could we see them?
I guess so, yes.
No questions yet, says the moderator. Okay, there are no questions yet, so let me take one question. So can we expect that we will have in 1 or 2 years from now a Swiss standard for this building models, an official standard, so that we, in a similar way as you did it with Interlis before everybody else started, so you will have the 3D building model standard where all others can follow some years later, or what is the situation in Switzerland?
Yes, I would say, I mean, we developed this idea now from the Swiss demands, the Swiss needs. It will cover not only the overground buildings, but also the underground buildings. I did not elaborate a lot on that. But at the end, I mean, for sure, when we have published something, it will be available for everyone, and we would be very happy to use it also elsewhere, because that's the nice thing in Switzerland. We have a really good strategy towards open data. We have a huge load of data now published, also governmental data. And so my expectation is that we will see also the data publicly available, associated with that as well, the data model, capture rules, and all that stuff.
That's great. Sounds good. So we have no questions in the window, but that is also due to my fault that I did not encourage people before that, but I will do that now. So please feel free to put your questions whenever they come into your mind, into the question window, and we will take care of that. Or feel free to say hello from here and there, because I can still not see who is with us here, and it would be nice to have a bit more interaction with you, the audience. So feel free to oh, you do see a question in the comment. Oh yes, here's a question. How did you validate the complex building models? Says, how did you validate the complex building models? Can you comment on that, Jörg? He's already muted, I think. Well, okay, so let's go ahead and with the next presentation, and we shift the the questions to say a short wrap up at the end. Okay, great. So let's go. Oh, I see just. Okay. Yes, you can read the answer of Jörg. That's great. Yes, we can follow the chat window here. I think you can all see it. So this is also a way. And if we have time left, we will wrap up at the end of the session as well. Okay, so let's move on to the next speaker, Hai Peng. Hai Peng is from China. And he's going to talk about method and practice of quality inspection and evaluation of the land cover classification achievement in the geographic conditions monitoring project. Quality inspection and evaluation is always with us. We are known for that. Jörg was just talking about, and you will talk again about this most important topic. So, Hai Peng, the floor is yours.
Okay, I'm ready. Hello, everybody. Let me share my PPT first. So is it okay? Hello? Hello? Hello, Hartmut. Dear Hartmut. Can you see my PPT?
Yes.
Okay. So first, let me have a briefly introduction of myself. Yeah, I worked in the National Quality Inspection and Testing Center of China, in Beijing. I have worked for some state level surveying and mapping projects, yeah, for several years. Tonight, I'm very glad to have this opportunity to talk with you. But I must confess, it is a little challenging for me because it was only morning in Beijing. Yeah, it's 2 o'clock. I'm trying to introduce this topic. Yeah, introduce this topic, and I wish you will be interested about this topic. So the title of my topic is Method and Practice of Quality Inspection and Evaluation of the land cover classification achievement in the Geographic Conditions Monitoring Project. It's about data quality control of the ongoing Geographic Conditions Monitoring Project in China, and I wish it will be interesting. Let us begin. Let us begin from the introduction of the geographic conditions. Geographic conditions is a fundamental component of basic national conditions, which reflects the spatial distribution, features, and the interrelationship between natural and human geographic elements. In 2013, China launched the Geographic Conditions Monitoring Project, hereafter called the GCM project, which is a dynamic monitoring of the geographic conditions of the entire country. By integrating and making full use of existing information and the latest innovative surveying and mapping technology to carry out general survey and dynamic monitoring of national geographic conditions, and to release monitoring result and analysis reports in a timely manner so as to provide a basis for scientific and sustainable development. Hence, to assure high data quality of the final achievement, quality control is undoubtedly a key procedure of the GCM project. As one of the important achievements of the GCM project, the land cover classification achievement, hereafter called the LCC achievement, is unique with the spatial design and application of classification system, remote sensing image data source, producing way, and the data model, etc. Firstly, it is designed with a hierarchical and detailed 3-level classification system with 8 first-level class, more than 50 second-level class, and over 100 third-level classes. Secondly, the mid-level high-resolution remote sensing images are fully used as data source, such as Ziyuan 3, China's first civilian high-resolution stereo mapping satellite with resolution 2.1 meters, and Gaofen 2, China's first sub-meter resolution civil satellite, 0.8 meter resolution, and also WorldView 2, and the air filters with resolution better than 1 meter. Thirdly, an integrated producing way is applied, including comprehensive indoor interpretation and field survey and on-site check and indoor data compilation. Furthermore, the achievement is collected and stored in vector data model of polygon, which is of continuous spatial distribution without gap and overlap. The design and application of the classification system, together with the remote sensing image data source and the integrated producing way, provide basic guarantee for data quality of the LCC achievement. However, due to the complexity and the diversity of land cover, also the varied geographic phenomenon and other objective factors, there are still some errors in the achievement during production, such as positional error, omission error, and the classification error, and so on. To ensure high-quality achievements, the GCM project has established a set of strict quality control system of 2 inspections, 1 acceptance, in-process sampling, reconfirmation. In this quality control system, quality inspection and evaluation of the achievement plays a crucial role throughout the entire production process. So, the prime problem to carry out effective quality control is how to design reasonable quality evaluation criterion for the achievement, including quality elements, quality measure, qualified target, and so on. Referred to the quality evaluation criterion of traditional digital surveying and mapping achievement, the quality elements of the LCC achievement are designed and shown in this table. It should be noted that the acquisition precision and the classification accuracy are the 2 core quality elements. Firstly, the acquisition precision. It represents relative matching precision between the outlines of land cover polygons and the image data source, and normally better than 5 pixels. And the qualified target of the acquisition precision is shown in this table, where the letter R represents percentage of error ratio, and M represents total number of errors, and the capital letter M represents total number of the LC polygons of 1 unit achievement, and the R0 represents acceptable threshold with 0.3%. And then move to the classification accuracy, which is the most important quantity element of the achievement to highlight core quantity requirement. Firstly, the classification correctness should be evaluated separately from the attribute correctness, so that the quantity evaluation method of classification correctness can be designed in a targeted manner. Secondly, it is necessary to combine the completeness and the classification correctness into one quality element of classification accuracy and adopt a unified quality evaluation method. To realize quantitative and scientific quality evaluation, the misclassified area ratio is used as quantity measure of classification accuracy, which can be calculated by the misclassified area of net-count polygons divided by the entire area of unit achievement. And then is a quantified target for the classification accuracy. By thoroughly considering the technical feasibility and the application requirement, the final quantified target for the classification accuracy are determined and shown in this table, where M represents the misclassified area and the capital letter M represents entire area of unit achievement. And the misclassified error ratio should not be more than 0.3% for the first level class and 1.2% for the total of second and third level class. Take a sample unit LCC achievement as an example, which has around 2,600 LC polygons, and the area is around 28 square kilometers. For acquisition principle, there is one error, so the inspection result is 0.04%, and we got quality score 95 in 100 mark system. And the classification for classification accuracy, we have 39,000 square meters for the square meters misclassified area for the first level class, and also 81,000 square meters for the second and the third level class. So the inspection result is calculated as 0. For the second and third level, it is 0.29, and for the first level class, it is 0.14, and we got the quality score as 81.7, and the final quality score of the unit achievement is 81.7 with minimal method used. In practice, the inspection and evaluation method of the achievement has been all around applied, and effectively guided the implement of inspection and acceptance of the GCM project for the indoor check and also field check. To conclude, based on the systematic analysis of the LCC achievement, we put forward a suitable quality inspection and evaluation method, which has achieved good performance in the quality control practice of the GCM project. Firstly, the design of the quality elements of the LCC achievement can meet general quality requirements and also can highlight key quality requirements. Secondly, the use of the misclassified error ratio as quality measure for classification accuracy makes the quality evaluation indicators to be intuitive, easy to operate, and highly adaptable, so as to realize a quantitative and scientific and operable quantity inspection and evaluation. So that's all. Thank you very much. 谢谢。
Stage. Oh, yes. Yeah. Here I am. Yeah, thanks a lot, Haipeng, for this interesting presentation. At the moment, I do not see questions. If I'm right, if I'm wrong, please, Christelle or somebody else, write me something in the chat, but I do not see questions or comments so far. So, oh yes, I have a question here. Can you bring up the speaker again to the screen, to the stage, please? What kind of satellite? Yeah. The question is, what kind of satellite imageries did you use to differentiate as a major and reference? Could you explain about the application of which satellite images have been used in each step of interpretation? So the question is, do you have used, what is the reference and how did you check it?
Yes. To say the satellite imageries, yes, we mainly use China civil satellite such as the Ziyuan 3 and Gaofen 2. I have introduced in the PPT. Yeah, it's meter level high resolution. To say the major and the reference, as a state level project, we did this GCM project regularly every year. So it's a big challenge for us to collect enough imagery to cover the whole country. And usually we have one data source, one kind of image. For example, we use the Ziyuan 3. Ziyuan 3, it's 2.1 meters resolution. And sometimes we get some better resolution. For example, the Gaofen 2, it's better than 1 meters, 0.8. Yes. We choose yes. Okay.
Yeah, I have one more. This is the last question for now. You can put more questions, but that we are going to answer later. But there is one question. How did you define classification? How did you define the first, second, and third level class? Can you explain?
Yes. You see, we reference some international classification system, and also based on some regulations, the land use and some land use. Also, we have some base geographic information classification system. Yeah, we just merge this classification system, and we to meet the requirements of the GCM project. It's want to carry out dynamic monitoring for for natural and human elements. Yeah. So the classification system is a very detailed 3-level class. Yeah. Okay.
Okay. Thanks a lot, Haipeng. Thanks a lot once again.
That's all right.
And is Markus ready to present?
Yes, I should be ready.
Markus, yeah. Can you share your screen?
Yeah, now it should be.
I'm going to introduce you. Oh yes, Markus Seifert from Germany will talk about smart mapping, the new vector tiles map of Germany. Even in our modern times, of course, we as human beings are still at the end of the process chain, and our brains are not purely digital, so we need something to see, and still we need maps. and Marcus is going to talk about that, to give a talk about that. Yes, the screen is there. Marcus, the floor is yours.
Yes, thank you, Hartmut, for this introduction. You're actually right. So we need maps for understanding our very complex environment. So what I'm going to present here is the latest development in our mapping agency in Germany, the vector tile map. Maybe we have to oops. I cannot control the presentation. No. The situation today. So when you look around in public administrations or to any user, they're using OpenStreetMap. So I think you are quite aware of this problem, and we would rather use official data rather than the OSM data, and that's why we launched a question a couple of years ago. The key question was, how look the official map of the future look like? So we are convinced that we need maps in the future, even if we have all of these nice artificial intelligence and big data out there. So, but at the end of the day, we need maps, and we are considering the question: how should it look like that we have a user-friendly application for any user out there? So therefore, we introduced this project Smart Mapping, where we actually consider this question and come up with a concrete application and implementation, which I'm talking about this presentation. So for this Smart Mapping project, we had to make some design decisions in order to implement a web application. So we wanted to try to implement an easy-to-use data model rather than a very complex GIS data model that nobody can actually digest in any application. So we want to come up with an easy-to-use one. We considered to use modern technology. So actually we implemented a vector tiles application with an open API to get access to that. We want also to serve mobile applications with, as you can see on the right-hand side of the screen, but also for desktop applications. So both are our target. We strictly use open source software. So this was a political objective of our project, that we had to use open source software for this kind of application, and therefore you can easily reuse these kind of things. And what is unique for our federated country is that we now have a central data processing established for this product. In former times, it was 16 states actually have done this kind of processing, and now we have one central processing. We have very high actuality, so it's a fully automatic process, updating process. So within one day, we can update the map actually, depending on the different data we get from the mapping agencies all over Germany. It was developed by our own experts, by our own developers. We have some 10 web developers within our team doing all this kind of web application by our own in an agile software development. So this means that we didn't have a big concept at the beginning, but we just started with some ideas how to implement that and do it in an agile way. We use cloud technology also for the application. So in that case, we are quite modern for public administration, and we have also some traditional web services like the web map service for raster applications, and we can also print this map. And we have some guidance for tutorials and so on. What you get with this application, here you see some content of the new application. So of course you get the topographical map you see on the left-hand side with some hill shades, with 3D buildings. When you zoom in a certain level, you get these 3D buildings. You have also a night map for maybe for mobile applications when you are outside, and also some auto imagery is combined with all these kind of other data in one application. What is quite unique with the vector tile approach, that you can easily change the styling, because the styling is done by the client and not by the server, so you can easily change the styling, and therefore we have a so-called map editor where you can do that interactively in a cloud solution. And you can save this kind of change in your styling, and also publish it on your personal website, for example. So this is quite unique, that you can easily take this data and application and implement it in your own application. What is really brand new, so it isn't launched yet, but it's ready for launch. So we have 3D buildings in the level of detail 2. That means we have the roof structure also implemented in this vector tile map all over Germany. That means 20 million buildings with the roof structure. So it was quite a challenge to do that in a performant way. So what is the main benefit also for us? So this is a data integration issue. So we have figured out that people use our map as background information and want to add their own data. And with this vector tile approach, it's very easy to do, like you see here in this application, where we displayed in a heat map, so-called heat map, all the locations of windmills, and here you see the density in a map where a lot of windmills are and where less windmills are in the country. And you can do it for all over Germany in this heat map. And the aspect of data integration was the most important thing for us, that any software developer can use this infrastructure also for integrate technical data that we don't have actually in the public administration. So it's much more than a map, so it can easily be used for integrating other data. Here another example where we wanted to highlight historical sites in a 3D visualization. So this is also a very easy task when you have vector tiles, because vector tiles are very intelligent data, so-called, where you have all the attributes that you have in your original database, also in this web application. You can easily select this kind of object that you want to highlight, like here, these historical buildings, and highlight them in a different style than the other buildings. And the application is ready for historical interested people who actually want to know where are the historical sites in a city or all over the country. Another application was in the city of Hamburg, where we tried to integrate a tree cadastre with our data. Here you see all the trees in Hamburg that are combined with our data, and this was also a nice application which you can use for a lot of things in the spatial planning or environmental issues, where you can easily also get some information about the trees and maybe also shading issues and so on. One other benefit of that approach is that we can use any open source software that are out there for doing web application, but also like QGIS, you can use it also in a GIS local environment, and you can download these kind of data and use it for your application. So my conclusion of this endeavor would be that with this kind of technology, we now overcome the the identified shortcomings in terms of why people are using OSM data instead of public administration data. So we are convinced that we now going this in the right direction with this kind of application. When you remember just the wide range of different applications we can do with that. So the HR software development was also quite a unique experience for public administration. Usually we write big specifications and give it to some companies that implement these kind of concepts, but now we have done it by our own, and so we can easily adopt new technology and can react on user requirements and so on and so on. This is also quite unique approach. So at the end, we hope that our data, the official data, will play again an important role in the decision-making processes, also in future, like it was in former times where only our data was available. But now I think we have some advantages compared to the OSM data. So hopefully this will come into reality in the next future. So this was the end of my presentation. Thank you for your attention, and I'm open for any kind of discussion or visit our website. Here you see the URL if you want to go to this and look at your own. Thank you.
Am I on the screen? Yes. Yeah, thank you, Markus, for this presentation. As you can see, the development goes towards 3D in one way, and it goes towards distributed systems and access from many different places. And I have several questions. Okay, I have one question here. You can see from Jörg Lüthi, the sample tree cadastre. The data integration in the back? Is the data integration done in the back end or at the client side? Who does the data integration of these two sides?
So it's done in the back end. So what we actually providing is the vector tile API, where you can get access via the service, the vector tiles, and these are the ready-to-use data as you want. And all this kind of data processing is done in the back end in the fully automated process.
Mm-hmm. Okay, great. And I have another question here. What methods did you use to develop your solution in your agile approach?
So when I understand correctly, method. So it was we use the Scrum method for this agile development. That means we have these so-called sprints every 4 weeks, and the developers get some task and do the task over the 4 weeks, and then we have a retrospective and see what they have reached and so on. And we have done that the last 1.5 years, and I think it was quite successful to have the developers within our team and doing this kind of Scrum methodology to produce a software as you want, and all this kind of data processing. So it's not a trivial task to get these kind of vector tiles for, as you see in this one example, with 20 million of buildings all over Germany. So it's quite a huge task to get the data, process the data, and provide the data as vector tiles.
Mm-hmm. Okay, yes, time is running. So thanks a lot once again, Markus. And we will move over to the next presentation from Japan this time on integrated geospatial information for sustainable land development in Tirana, tourist area in Albania. So the presentation comes from Japan, and the project area is in Europe, and welcome to SAR, and please start, and the floor is yours.
Mute my mic. Can you hear me?
Yes, we can hear you. Yes.
Okay, let me share my screen now. Can you see my screen?
I do not see your screen. You have first to share it. Share your screen. Press the plus sign and then. So, oh, yes. Yeah, it's coming. Yes, great. And now go into the start the presentation mode.
So I'm going to talk on integrated geospatial information for sustainable land development in Tirana Duris area in Albania. It's JICA TF project, digital topographic mapping and capacity building of ASIG for utilization, maintenance, and updating ability. In 2017, it started. So I'll introduce the objective of the project, key technology, working framework, capacity building, and technology transfer. Finally, conclusion. So introduction. Unplanned rapid urbanization was creating severe pressure on urban infrastructure and environment, particularly due to concentration of population in and around Tirana Duris area, which is capital city of Albania. So key issue was lack of infrastructure, transportation, such as water supply, wastewater, and solid waste management. Problem with property registration, improper and unplanned development. So countermeasures taken by the Albanian government, National General Plan for Territory of Albania prepared, an integrated plan of Tirana Duris area in specific. In order to implement these countermeasures, geospatial information are indispensable. However, no new large-scale digital topographic map and limited technology and experienced engineer with ASIG. So objective of the project was to creating 20,000 digital topographic map of Tirana Duris area and capacity building and technology transfer for data creation and quality control of the state or city of geospatial information. In short, it's called ASIG. This map shows the location of the project. So there is this is Tirana Duris this area, this coastal town, and up there, this mountainous area. So the total area of the project.
Mr. Shah, sorry to interrupt. May I kindly ask you to put your presentation on presentation mode and then click to the slides that is where you are talking about? It is,
yeah, I put it on presentation mode. So can you see it?
We do see your screen and your slides, but we do not see it in presentation mode. So you need to press, or you can press F5 on your keyboard, or you can press the button. It is, well, the icon at the right bottom, so to say, of your screen. And then it's, well, I think the most left one. You can also,
Can you see my slides now?
yeah, we do see your slides. What you can also do is select the slide that you are talking about in the left side of your screen. There you see this different slides.
No.
No? Okay. Is it possible to press F5 and then put it in presentation mode? Okay, I think we go to the next speaker and we try it later on in this session.
Yes, so let's fix these technical issues in the background, and in the meantime move on to the next speaker, or in fact the last speaker. The last speaker is Jeannette Storm from the Netherlands. Hi Jeannette.
Hello.
Good to see you here. And Jeannette will speak about the success and growing use of geodata, and the success asks for integrated information supply. Yes, sorry for reading this not in the right order. Yeah, please, Jeannette, the floor is yours. And in view of we are a bit running out of time, so I would appreciate if you could stick with, well, say 12 minutes or so if possible. The floor is yours, please.
Okay. Well, thank you. I'll try to keep it a quick presentation. Well, I'm from the Cadastre Netherlands. I'm working as a product manager for our key register on addresses and buildings. And I will guide you through the activities that we did to make this address and buildings register a success also for the users in the Netherlands. Let me see how I get to the next screen. Okay, the addresses and buildings is a law in the Netherlands. So it's a register, a key register, and it's we have this law and this register since 2009. The use of the data came into force. The law came into force in 2011. So the use started in that year, and by 2011 it was a nationwide register maintained by all the municipalities in the Netherlands. This law was only since 2009, but in 2014 we had to evaluate. That was what we agreed in the law upfront, and that led to the changed law in 2018. The buildings and address register is part of our system of key registers. We have a system of key registers that is a combination of location-oriented data, the ones indicated with a map, and here is the addresses and buildings register. But for example, also the Dutch Cadastre is a key register, and the persons register. The Chamber of Commerce is also part of this, and all this data together makes a base layer for all kinds of governmental activities. But for example, the addresses and buildings, as most of the location-oriented data is open data and used widely both by the government and private parties. So I would like to ask a question in the poll. And I know it takes a bit of time to type in the poll, but I hope you can see it in a few moments. I guess in the chat field, but I'm not sure. And my question is, do you also have a nationwide register for addresses and buildings, combined or separate? And I heard in the first presentation that Switzerland is working on it, or at least elaborating on it. So I'm curious how this is for the other people here. I have no idea whether you already see the poll or not. Maybe Marcus or Christel, can you explain to me whether there's a poll, or should I go to the next slide and keep on talking?
No, if everything is okay, the questions are already in the poll, and you can click on the polls button next to the chat function. And for the first question, you need to scroll down a bit because he does it in the other way around. So if you push the polls button next to the chat and scroll a little bit down, then you see the first question: does your country have a nationwide register for addresses and or buildings?
Okay, I think it's only visible for the viewers. So I don't know what kind of answers either.
Okay, then I can give the result, but because the yes is confirmed by 38.9%, no is 27.8%, and in progress, oh, it's a little bit, it's still, the people are still voting. So I understand, Jeanette, that you cannot see the results.
No,
okay.
At least I don't know where to see them.
Then
I don't see anybody.
Okay, then I have the honor to to announce them.
Yeah.
So yes, I think people now stopped voting. I don't see any changes anymore. So yes is 42.1%, no 23.8%, and in progress is 27.3%. So the winner is yes.
Okay, so that's quite a variety of answers, but also quite a lot of spectators are used to having addresses or a buildings register. I will soon come to the next question. Let me see how I can. In the case of the Netherlands, we have a website, a viewer website that shows our addresses and buildings register. So although it was initially initiated to help the government and to make sure that everybody uses the same data all the time and the correct data, it is also available for private users. So a lot of people use this open website. The link is also in the screen. So if you want to look around, this is our building in Apeldoorn, our head office. Which has been a long time that I've been there, but you may understand why. It's still there, and hope to go there soon again. So this is identified in the addresses and buildings register, both by the building and some basic data about this building and the address. And this is the authentic data on the information that's in the register, and used via this website, but also used via lots of other types of products, and I will get back to that later on. One of the success factors in our case is that it's open data and easily available. So my next question is about the openness of the data. This is some details about what type of information we have in the addresses and buildings register. Well, when you look into the Bach viewer, as I showed you the URL just now, you will see all this type of data and have a look around. And I'll stick to this brief explanation. And then go to the next question. I'm curious whether in your country this data is also open data like it is in the Netherlands.
Yes, I'm supposed to give the results here because I can see them in the session window. It's visible, so I can.
It feels like a Eurovision contest, but let's see.
Yeah. It's like that. It says is address and building data available as open data in your country. yes say 5 votes, 20.7%, and yes with restrictions says 40.9%, 9 votes, and no is 36.4%. Well, it just changed a bit, 35%. Yes, that was the last poll, I think. Yes, the other was does your country have a nationwide register? No, that we did already.
No, that's
this
what,
was the question. Is it right? I'm a bit
yeah,
confused.
yeah.
So
that
25
makes,
yes, 42% yes with restriction, and 33% no.
Okay, so that's also quite a variety of answers, and makes me very curious about the yes with restrictions. But maybe we can get back to that in the questions and answers session later on. I will go to the next slide now to address the situation in the Netherlands. So a little explanation about how we started. As I explained, in 2011, the use of the data started. Use was really limited in the early years, and that's also showing in this graph. We saw that although use grew back then also quite fast, it was a very simple and restricted available website, no map included, and quite difficult to use. So one of the actions that we took back then was to make this viewer, as I showed you just now, the previous version, but it was a viewer with a map and easy to click on and open for the public. So that really helped to make the data accepted by a wide range of people. And also to make it visible, that it existed and that you can use it. So only in the early years we already saw that the original simple application that we had with restrictions, the requests grew, but as soon as we launched a viewer, we saw that not only the number of requests climbed, we saw also a lot of more visits in that time. So my next question is about how many users do we have, or actually how many requests did we get in the last year? And then a combination of all our web services that we supply from the cadastre to the users, mapping, APIs, feature service. And there's 4 categories, and I hope you will type the answer in the right category. Well, then I will ask again whether Christel or Marcus can give me the votes.
Yes. Oh, yeah. I have always to wait until I'm on stage here. So we have only 6 votes. now 7 votes, and it's, well, to say less than 10 million, and the next is 3 votes, and between 100 million and, oh, this is too many zeros here, is 3 votes. It's equally distributed, but not many votes. So the same for the first option, second option, third option, basically.
Okay, well then I'll give the answer that was the actual situation. It was about 3.5 billion, so the last answer was the correct one, which is a huge amount of requests, mainly by the WMS, the mapping service. That's the blue part. And as you can see, the years that I showed before, well, you don't see them anymore when you look at the graph in the next years. And it's still growing. And the types of requests or the types of products that are used that vary in time. Congratulations to Ivan. And makes me curious how it's used in other countries, and whether there's maybe differences between open data or non-open data, because I think these numbers we get mainly because of the easiness of getting the data, and also that it's open data. So I will proceed to the next slide. These are some examples of organizations that make use of the addresses and/or the building data. And then I will go to the key success factors. We have recognized them as quality priorities. So prioritizing the quality issues to make the data fit for use. The second is availability, and I will get back to all 3 of them on the next slides. And continuous development is also a key factor. Before I will go into the details about these key factors, I will give you some background information about how we have organized things. And we'll go to the next slide. The Addresses and Buildings Register is a responsibility of the ministry in the Netherlands. I see that's, well, it's a ministry, now the Ministry of Internal Affairs. An important role is by the municipalities, because they are responsible for the data. My role is within the cadastre to make sure that all the data comes in correctly and goes out to all the parties that want to use it. But that's more in a support role and a technical facility role. We, as cadastre, do not maintain the data. That's the municipalities, and we work together with them quite intensively. But the main job about the Address and Buildings Register is done in these municipalities. Then there is the council or the board with municipalities and users. This was organized since the beginning, and it gives us a balance between how good we can maintain the data and what we do it for. So, for example, the Central Bureau of Statistics is part of this board, but also the Tax Institute, the Chamber of Commerce, because they all are obliged to use the data, and they depend on how good we present that.
Can you please wrap up, Jeanette?
Yeah. Then I will go to the last slide. the three success factors. One about quality, and we provide quality support, and we have over time organized the way we handle quality, so that helps also the user friendliness. Now there is availability, and that's, for example, the way we proceed with what kind of products we supply and how good they are available 24/7 and as open data. And for example, factor tiling, as I heard in one of the earlier presentations, is one of the types of products that we are investigating. And the last slide that I will present is about what the new developments, because we're continuously developing to stay in contact with users and to adapt to their needs and requests. And in the near future, we will see more integration of the different types of data and towards 3D maintenance, but first supplying the data in combination with 3D information. So I hope this wrap up was quick enough. And I'll leave it to this.
Can you please? Oh yeah, yeah. I've always to wait to be on screen. Yes, thanks a lot. Thanks a lot, Jeanette. I just want to present the your last poll. The results was 7 votes for open data and 6 votes for quality, and no votes for the one vote for user influence is now coming in. So this is the result of your last poll. So you can comment on that.
Very nice that was also asked. That's one to start a discussion about, of course, but I'm not sure if there's time for that.
Yes. So we have. Yeah, we have. I think we have one. It was only a comment. In Canada, parcels are used in spatial information systems, no buildings or addresses. Well, that's a comment. Yeah. Do we have other questions here? I do not see in the chat. I do not see a question, and I do not see either here. No questions? Comments? No. No questions, yes. No further questions.
Okay.
So thanks a lot, Jeanette, for this interesting insight into the Dutch system. It was really interesting. And now let's try give another trial. The previous presenter, can you? Yeah. So, would you mind to try to share your screen? You can do one more trial, or if not, I would say you can take 5 minutes to wrap up your presentation to tell us what you think is the main message you want to give us in a very brief way. That's also a possibility. In that case, without slides. Oh, he says he cannot hear me. Can others?
No, I don't think we can hear Mr. Sasso.
Hello, can you hear me?
Oh, now you can, yeah, can you hear us? Can you hear us? So it looks, it's not possible at the moment. Christelle, what do you think?
Hello.
Yeah, we hear you, but you don't hear us, obviously. Can say you can talk for 5 minutes.
Can you hear me?
Yes, Mr. Shah, we can hear you clearly and we can see you. If you can hear us as well and see us, or at least hear us, then
Can you hear me?
yes, we can. No, I don't think.
Yeah, but he obviously he doesn't hear us.
No.
So
Yeah.
so okay. What options do we have now? Question to Christelle, to you. No options. We can hear him, but he cannot hear us. So either I asked him, I put him the offer in the chat that he can talk for 5 minutes, but obviously he disappeared. No, it says thanks for the attention from the techniques board and welcome to the Ask Me Anything session. So where is the Ask Me Anything session? See the link in the chat. Okay. Does anyone see a link in the chat? I do not at the moment. So, but it looks that we have to, oh yes, here it is. So please use this link here that is in the chat. Please all use this link. And obviously we have to move to this Ask Me Anything session. So we can continue our talk there. I really invite all speakers, all the audience, everybody who joined us. Sorry for all technical issues here. And please join us in the session that you can see here in the link. I'm going to click the link and hopefully we meet each other in a couple of seconds or so.